can you solve this math challenge? Here's the question. Solve for the real value of a given that 3 minus a equals logarithm of 9 minus 2 raised to a to the base of 2. You can pause this video if you want to give this problem a try. And now, let's answer this question together. Now, in this question, we will use three concepts. The first one is the concept on logarithmic equation, the second in an exponential equation, and the third one in a quadratic equation. So, let's start. To answer this question, we will use this concept. If we have c equals logarithm of a to the base of b, this can be written as b raised to c equals a. Therefore, this equation right here, 3 minus a equals logarithm of 9 minus 2 raised to a to the base of 2, can be written or can be expressed as follows. We have 2 raised to 3 minus a equals 9 minus 2 raised to a. Now, from logarithmic equation, we now have an exponential equation. Alright, now let's continue. Let's use this law of logarithm. If we have b minus a minus c, it is equivalent to b raised to a all over b raised to c. Therefore, 2 raised to 3 minus a can be written as 2 raised to 3 all over 2 raised to a. Now, 2 raised to 3 is just 8 because 2 times 2 times 2 is 8. And then what we're going to do here, to cancel out 2 raised to a on the denominator, let's multiply both sides by 2 raised to a. So 8 equals 2 raised to a multiplied by 9 minus 2 raised to the power of a. Next, let's distribute this 2 raised to a. So we have, on the right side, we have 9 times 2 raised to a minus 2 raised to a quantity squared. Now, since we have two similar terms, what we're going to do is to replace this with another variable, and let's call this as y. So, all 2 raised to a becomes y. Now, as you can see, from logarithmic equation to exponential equation, now we have a quadratic equation. So, let's solve for the value of y. From here, let's rearrange some terms a little bit. So, we have y squared minus 9y plus 8 equals to 0. Now, y squared minus 9y plus 8 can be factored as follows. We have y minus 8 multiplied by y minus 1. Take note that when we multiply these two factors, this will bring back to y squared minus 9y plus 8. Now, let's go back to its factored form again. And now, since it is equal to 0, it follows that at least one of them must be equal to 0. So we can say that y minus 8 equals to 0 or y minus 1 equals to 0. Now, solving for y on the first equation, let's add 8 on both sides. This will give us the value of y as 8. On the second equation, let's add 1 on both sides, so we have y equals 1. Now, we know that y must be equal to 2 raised to the power of a. So we can replace all y with 2 raised to a. Again, we go back to an exponential equation. Now, let's focus on the first equation, 2 raised to a equals 8. Now, 8 can be written or can be expressed as 2 raised to 3. Now, we have two equal expressions and we have equal bases. Therefore, we can say that their exponent must be equal. So, a must be equal to 3. Now, on the second equation, this 1 can be written as 2 raised to 0. And again, we have two equal expression with two equal bases. Therefore, the exponent must be the same. So we can say that a equals 0. Therefore, in this equation, 3 minus a equals logarithm of 9 minus 2 raised to a to the base of 2. We found two real values for a, namely a equals 3 or a equals 0. And as always, we are done.